Alright, welcome back. Let's get into the Ordovician, shall we? So that's what it looked like during the Ordovician. It's kind of what North America looked like. Just keep mental note of these things, where Laurentia in North America is, transgressing and regressing seas, with exposed continent, is it covered? And so here we are, in the Ordovician, both oxygen and CO2 will start to increase, and we start to get a glaciation toward the end of the Ordovician. So the Ordovician just kind of came about because there was an argument between where the Cambrian ended and the Silurian, which is the next period, started. There was some overlap, and they finally just said, well, let's just make that its own period. It's the Ordovician period. Scientists, during the late Ordovician, you get massive glaciers forming at the South Pole, causing the sea levels to drop, which could be a factor in the period ending with a mass extinction that we'll get to. There was obviously organisms, but there was a sudden abundance of trace fossils, footprints, poop, burrows, tracks, those sorts of things. And again, there's an extinction event that occurred at the end of the Ordovician. So during the Ordovician, we're finally starting to get some very primitive plants moving onto land, which again was barren until then. It was just rock. Lycophytes. Lycophytes are these type of plants that finally begin to move onto land. Later, other types of plants would kind of make their way onto land, but it's kind of started with this class of plants called lycophytes. Oceans is where the majority, obviously, of the life is. It became filled with invertebrates of many types, things without a backbone. Fish first start to evolve, but the animals still stay in the water. Plants starting to make their way on land. Animals still only in the water. So therefore the ocean was teeming with all kinds of different life coming out of the Cambrian, bivalves, gastropods, kind of snail things, crinoids, called sea lilies. So it's just a bunch of diversification of more ocean life. And then the first kind of coral reefs appeared during the Ordovician. So this is kind of what we see starting to evolve during this time. So we still have trilobites, but we're seeing things like these sea snails, these crinoid sea lily things, brachiopods, these things that look like seashells. So this is kind of the stuff we start to see. Again, if you look in the background, there's really nothing on land. Let's start with these little itty-bitty plants. And these are those lycophytes. These are modern-day lycophytes. So obviously these weren't the exact things that were on there. But these were this class of plant, the first to kind of make its way onto land. These are lycophytes. Now, as we get towards the end of the Ordovician, as we get into the Silurian, we see a rapid decrease in the number of types of species, genera, those types of species. So we see a massive drop. And during this extinction, 86% of all life went extinct. That's a lot. But there's ones that are way, way worse. So let's talk about that real quick. So this obviously devastated marine communities because that's where most things are living, in the ocean. It was the first major extinction event recorded in the rock record. It was a result of, hypothesized, a single event, and that's the glaciation of the supercontinent Gondwana. When Pannotia began to break up, Malaysia and Baltica and a couple other things started to move north, the leftover mass is called Gondwana. And it was thought that the glaciation of Gondwana is what aided in this extinction. There's evidence for this glaciation that can be found in places that don't currently have glaciers, like the Sahara Desert in Africa. When the glaciers formed, that water water's got to come from some level, so when glaciers form, sea level drops. Oh, by the way, one thing I wanted to point out up here, and you'll see these for any of the extinction slides, is that this extinction occurred over a 5 million year period. One thing I want to get across with extinctions, they don't just happen and then everything's dead. It takes a long time. Now, 5 million years seems like a long time. Geologically, that's not a long time. It's almost nothing. Right? But to us, that seems like a long time. So 5 million years, again, seems like a long time, but this is how long things take for the atmosphere to change, for sea levels to change. It takes time. So the extinction aren't just this fast thing. Even the extinction with the dinosaurs, we'll talk about that when we're talking about the Mesozoic era. But in any case, so if you have glaciers forming, you have sea level dropping. Well, where do most things live? They live in the sea. And if there's less of that, they're going to die. So again, the drop in sea level reduced the prime habitat on continental shelves, those shallows of the ocean where most of these things are living, which, if the water goes away, if the habitat goes away, things die. So as the water receded off of the cratons, it didn't have that shallow marine environment, so things died. So this was due to glaciation. So again, we're seeing that kind of here as well. That's kind of what we're seeing. And we'll look at this chart for each of the different periods moving forward. Again, these are just examples of organisms that are affected by the subsequent major mass extinction. It's not like every single thing is extinct. Every type of brachiopod, every type of trilobite, but these are the things that are severely affected by this mass extinction. So this first extinction during the Ordovician, brachiopods, these seashell things, trilobites, these are the things that have been majorly affected by this, because these things live in the shallows of the ocean. Those shallows would disappear. Move me a little bit. So in this artist rendition, again, the glaciation here, you can see, and as that grew on Gondwana, these shallows of the oceans kind of retreated off the continents, leaving these things exposed, leaving no habitat for these organisms that need shallow marine environments to thrive, and so that's what you have. Before we get too deep into this video, let me give you part of the super secret code. It is the number 5. 5. You got me the number 5. Excuse me. Okay, so here we are in the Ordovician. We're going to be tiptoeing into the Silurian here in the next section. We'll start to see more fishes, different types of fishes, corals as well, amongst many other things. We'll also we'll look at that slide usually at the end of each section, as well as now this one, because now we finally start to get plants evolving. So these are plants and kind of when they evolved. Just kind of really looking forward. This kind of blows my mind every time I hear it. Flowers didn't even appear until about 130 million years ago. Flowers. Food for thought. But in any case, so we really only have some of these basic plants that kind of have moved their way onto land at this point during the Ordovician and into the Silurian. So let's go ahead and pause here. When we come back, let's talk about the Silurian.